Hello friends, today I will solve the problem which is related to contiguous memory allocation. There are two types of continuous memory allocation. One is called static partition or fixed size partition. Second called dynamic partition or variable size partition. Static partition, this is the oldest and simplest algorithm technique used to put more than one process in the main memory. In this partitioning, number of partitions non-overlapping in RAM are fixed, but size of each partition may or may not be same as it is contiguous allocation. Hence, no spinning is allowed. Here, partitions are made before execution or during system configure. In dynamic partition, it is a part of contiguous allocation technique. It is used to alleviate the problem faced by fixed partition. In contrast with fixed partitioning, partitions are not made before the execution or during system configure. Various features associated with variable partitioning. Number one, initially RAM is empty and partitions are made during the runtime according to process need instead of partitioning during system configure. Second, the size of partition will be equal to incoming process. Third, the partition size vary according to the need of the process so that the internal fragmentation can be avoided to ensure efficient utilization of RAM. Fourth, the number of partitions in RAM is not fixed and depend on the number of incoming process and main memory size. First fit algorithm. The main concept of that first fit algorithms is algorithms start scanning the partition serially one by one. When a partitioning gets big enough to store the process is found, it allocates that partition to the process. In best fit algorithms first scan all the partition, then allocate the process, then allocate the partition of smallest size that can store the process. Third, in rest fit algorithms first scan all the partition, then allocate the partition of largest size to the process. Now, example, question number 1. Consider the following heap figure in which blank regions are not in use and hatch regions are in use. In given figure, just you will see here, 50, 300 kilobyte and 600 kilobyte are already used, and 150, 350 kilobyte in main memory are not used. The sequence of request for block R size is given: 300 kilobyte, 25 kilobyte, 125 kilobyte, 50 kilobyte can be shifted, can be satisfied if we use either first fit or best fit policy. Anyone? B. First fit but not best fit policy. C. Best fit but not first fit policy. And D. None of the above. Now see carefully according to questions. Consider the following heap figure. We know that in which blank regions are not in use and hatched regions are in use. See carefully. 50 kilobyte color, 300 kilobyte color, 600 kilobyte are color. It means it's used, and remaining 150 kilobyte, 300 kilobyte are not used. The allocation flow variable size partition scheme here. Let's, according to questions, P1 equal to 300 unit, P2 equal to 25 unit, P3 equal to 125 unit, and P4 equal to 50 unit. You can say that 300 kilobyte, 25 kilobyte, 125 kilobyte, and 50 kilobyte. Now, how it will be used? What type mechanism we can use here? Now, we use here first fit algorithm. According to algorithms, we know that according to algorithms starts scanning the partitions serially. When a partition big enough to store the process is found, it allocates that partition to the process. See here, P1 equal to 300 kilobyte, process P1 300 kilobyte. So 300 kilobyte, find out here. So it will be stored 350 kilobyte first for P1. P1 is stored here with 350 kilobyte because partition big enough to store. The 350 is big enough for 300 kilobyte. Now second is P2. P2 means 25 kilobyte. 25 kilobyte, where it will be stored? Again search first fit, it come out 150 kilobyte. 25 kilobyte, it will be stored in P2. 150 kilobyte next. 150 kilobyte, so it will be stored 25 kilobyte in given figure. See here, green color 25. Remaining memory 125 kilobyte from 150. Same P1 is stored 350 kilobyte, and then 300 occupy and 50 kilobyte is remaining here. Now third will be C figure. P1 already occupy 300 kilobyte in 350, and P2 also occupy 25 kilobyte in 150 kilobyte. Remaining have a 125 and other is 50. So P3 will come out 125. So P3 it will be stored in 150, 125 remaining in just after P2, P2, P3 occupy 125. Now see here both carefully. P1 occupy 300, remaining rest memory is free 50 kilobyte, and P2 occupy 25 and P3 also occupy 125. So only remaining memory space are free is 50 kilobyte, and P4 is P4 it will be stored 50 kilobyte. So 50 kilobyte I have already remaining memory space free in 50 kilobyte. So P4 is also stored in P4 occupy 50 kilobyte. Please see the carefully. So P1 also 300, P2 is 25, P3 is 125 and P4 are 50. All are process occupy the main memory here. Please see for second algorithms is best fit algorithm. According to definition of best fit algorithm, first scan all the partition that it then allocate the partition of smallest size that can store in process. It means those process is suitable for nearest smallest size or equivalent to free memory location. It will be stored there. In given figure, 50 kilobyte already allotted, 300 kilobyte already allotted, and 600 kilobyte already allotted. You have only two blank free space, 150 kilobyte and 350. Now first P1 will come out here 300 kilobyte. So just we can search one by one which one is the suitable memory is equivalent or near about. Then it come out 350 P1. So 350 it will be occupy 300 kilobyte. In here P1 denoted in figure, P1 occupy 300 and remaining amount have a 50 rest free amount. Now second P2 have 25 kilobyte, 25 kilobyte. So it will be stored again. See here best fit algorithms. So find out smallest size of which one the smallest and suitable for the store P2. So here 150 have a free and also free 50 kilobyte in near about P1. So 25 will be stored. So it will be stored in 50 kilobyte. Rest remaining free size it will be occupy 25 kilobyte here. 25 kilo stored in near about P2. So now next is free P3. P3 is 150. P3 is 150. So it will come out in given figure. P3 already occupy 125 kilobyte. Now next process P4. P4 have a 50 kilobyte. So in given figure haven't free space for storing P4. So process P4 cannot be allotted the memory. This is because no partition of size greater than or equal to the size of process P4 is available. Thus, only first fit allocation policy succeed in allocating memory to all the process. Answer.